So good morning, everyone. We're starting a new session today. It is called authentication. So we've done with cryptography, we've done with those math and those like interesting design that can make encryption possible, make security, like secure communication possible. And today we're going to talk about another interesting topic, which is to how to authenticate other people, like the use of password, etc. So this is going to be probably more like closer to your daily life. So I will be very happy if you can join this more interactive during today's lecture and talk to me, and then we can come up with interesting thoughts on the existing like authentication scenarios that you have come across in your daily life. All right, so before I actually talk about authentication, just based on the word, just based on this English word, can someone give me a guess, like what does authentication mean? Yes, please.
Making sure the person accessing the system is safe.
Yes, so making sure that the person accessing the system is like really the right person, is really you, right? Yeah, that's correct. And I don't know if you guys have heard about authorization before, but like for authorization and authentication, there is a clear distinguish. So before I talk about authentication, I will first want to clarify these two terms because it just like sounds similar, it looks similar, but it actually refers to different content. So for authentication is like, who are you? Like when I log into the system, I want to tell the system that I am truly me. I'm not impersonating someone else. And also like an attacker is trying to pretend to be someone else to log into the system, right? So that is about authentication. It's like when I pass this validation, the system that I'm trying to log in or the system that I'm trying to access will assume that the people who's doing this trial right now is truly me. Okay, and then for authorization means that I grant someone else or like the system grants someone to do something. So it's more of, what you can do. What can you do? Like I authorize you the permissive, or I authorize you the permission to say open the house, right? Like to use the key to turn it to open the house. It's like what you do for your secure the house assignment. So that's about authorization. You authorize someone to do something. So there's a difference between authentication and authorization. Authentication talks about who are you, and authorization talks about what can you do. And in this part, we're gonna majorly talk about authentication. And we have multiple terms for authentication. I just want to introduce those terms to you so that in the future, when I mention those terms or when you come across those terms, you know what they're referred to. So for authentication, first let's talk about a term called principal. So principal means the true person, like the unique identity, such as Tiffany, me, myself, is an example of principal. And like Adam is a principal. You know that person is Adam. And then when we talk about identity, it specifies a principal. And it is like an internal representation of entity. So think about this. So when you are having like using Discord, and you have your own handle, right? You have your username, and that is the identity of yourself. So it's like when you are using your own account to log into Discord, and then you are using that like username as your identity. And then in terms of the subject, it means that someone is asked on behalf of an identity. Yes, please.
But shouldn't this card usually be identified as a principal instead of being identified as an identity?
Identify as identity, or okay, yes, I think you're right. So I like, so when we do authentication, we actually try to identify that identity, but then I will talk about that a little bit later. So it's like when we do this authentication is to identify if the username is the right person, try to link between the handle over there and the true, like the, like as you said, like the handle, which is identity at this part. Thanks for correcting me. Okay. And then for authentication, it, as I said, like it bands identity to a subject. So it's like there is, acts on behalf of an identity, and then what authentication do is try to make sure that the correlation between the identity and the subject is correct. And I have an example here. So for example, I myself is a principal, right? And then I have an identity in GitHub, which is Tiffany B, and that's my identity, okay? So that's like my account in GitHub or my account in any other kind of a system. And at this point, there is a subject that tries to act on behalf of me. And there is a subject that tries to say log into the system on behalf of me using my identity, Tiffany B, all right? So in this case, authentication is trying to bind the subject who's trying to do this action with my identity, which is Tiffany B. So this is the authentication problem, or say this is the authentication process, all right? And in terms of authentication mechanisms, so can you come up with some examples, like what kind of authentication can manage or say can succeed in binding the subject and the identity? So I just mentioned about like the password or something like what you know. Okay, yes, please.
You're doing the password or biometric?
Yes, so it's like the password, right? Or say the is there anything that you can talk about? Did you just mention password?
Said username and password or biometric?
You said biometric, right?
Yeah.
Yes. So it's like biometric is a unique part that's in your body, so it's not going to be very easy to like impersonate or to deny, right? So yes, so that biometric is also one way to authenticate. What else? Yes. Yes, so it's like, you have a card and you swipe, and within the card, it has like the information about yourself, or say like by the time that you have like say ASU's card, your identity is encoded into that card, right? All right, so it's like what you process, right? So like the card is something that you have. And then like biometrics is something like what you are, right? Okay, and anything else? For example, VPN. So it's like VPN restricts where you are. VPN restricts the specific IP that you can use when you log into system. For example, like ASU, if you're gonna log into like some servers inside internally at ASU, that you need to either using VPN to access it, or you have to stay in campus in order to visit those servers. So those, this is another authentication mechanisms which uses the information of where you are. So only those limited amount of IPs that can be allowed to log into a particular system. All right, so those are some, some examples. And now let's go back to some formal definitions, some annotations. So for an authentication system, there are 5 essential elements. For example, the first is A. It means that the authentication information that provides identity. Okay, so for example, like password, and like for those information that we just talked about, those you know, the barcode, or say the code that is encoded into your ASU card, those are authentication information that can prove your identity. Okay. And a C represents complementary information stored on a computer and used to validate authentication information. And this may sound a little bit confusing right now, but later on we will talk about a real world case, and then we will plug in those notations into the real world case so that you will have a better like understanding of what it means by complementary information, what kind of complementary information can be stored and then used to validate authentication information. Yes.
Does the complementary information include the security questions that we have in our accounts?
Yes, the question is, does complementary information include the security questions that you usually have? And the answer is yes. So that is a very good example of complementary information. But later I will show you another example. But yes, here in this case, security question is a good complementary information. Oh, by the way, guys, I just see Zoom people also interacting, and I'm sorry that I missed you guys, those information. Like you guys talk about authentication mechanism. Thank you for that. I will not miss your message later on. All right, so the third part is F. It means complementation function. So it is a function, first of all. It is not like an information or like authentication information or complementary information, but instead it is a function. And then this function maps from the authentication information to the complementary information. So it's like you log into the system, right? And then you have your password, and then there will be like security question popping up asking you like, what is your first name? Or what is your mom's maiden name, right? Like those are the common security questions. And why they're asking this is because you set it up when you registered. And in order to ask you the right like security complementary question, they have to store that somewhere and also try to map, the system needs to map your personal identity to those correct complementary information, right? So this function guarantees that you can map from identity, authentication information to complementary information correctly. Okay, and then the fourth is authentication function that verifies identity. Identity. So that's the part that will tell you that whether or not this person, like this subject who's trying to act on behalf of an identity, is the true identity, right? So this authentication function will take the authentication information and complementary information together, and then return true or false. It will return whether or not you pass the authentication. And then last but not the least, S is selection function that can enable identity to create or change the current information in A or C. So it's like if you reset the password, or if you want to add in your security questions, you could use this function and then use this function to change those information. All right, so far so good? Yes?
What exactly word does the L stand for? Because I don't see an L in any of that.
What is the exact word does L stand for? So authentication functions is the word for L.
The rest of them, A for authentication, C for complementary, F for functions, L for what?
Sorry, okay.
See how it's A for authentication, C for complementary, F for functions, L for what? See that?
Which part is that? Here or the upper part?
All of the others have a term.
Oh, I see. Yeah, right. So this function returns either true or false. and it's called authentication. It's called authentication functions. Sorry for the this like misclarification. So it is not very clear. So here M is called complementation functions, and then like F takes A, which is authentication information, and outputs C. And then for L, it takes the authentication information and complementary information, which is A and C, and it outputs either true or false. And this is called authentication function, that it verifies identity, meaning that it returns whether or not this identity is true or false. Yes.
L is a logic function. The other one's just a regular function. Makes sense? So you got, one's a function where it changes one thing to another. L is a logic, it returns logic true or false.
Right, so this is it. You can consider this as return 0 or 1. It will return a binary answer for L function. Yes.
But not clear on complementation function.
Oh, this is complementation function. It's the name of F. And what it does is that it will output the according complementary information given the authentication information. Does it make sense? All good? Cool. Yes, so as George said in Zoom, so for L, it is a bool function. It's just the output of boolean value. Okay, so now let's continue. All right, and then now let's have a like an example. For example, like password system. Okay, so we try to plug in those locations later when we talk about password system. So like password, you can store it in plain text. Let's just right now assume that we store password in plain text, okay? And then for authentication system, we will first have a set of string that can be used for password. So it's like A is password string. And then C, which is like the complementary information, if you don't have secure question, okay? So if you don't have that, then you can just say complementary information is just A. And then you can have F, which is the complementary information function, right? And then that just like return, given A, return A. Because here C, which is the complementary information, is just A, okay? And then for L, it returns true or false, right? It returns a Boolean value, and they will just return, and L, an example of L can be an equal like equal function. And then we have an S function to change or set password. So this is a simple password system. But we all know that in real world, this is bad because we're not gonna have password stored in plain text. So later on, we advance that, and then we have Unix encrypted password system. Okay. And in Unix encrypted password system, first we have authentication information. It's a string of 8 characters or less. Although like now, if you are using like the true more advanced system, you will have, of course, longer password. But like right now, just talking about the original Unix encrypted password system. So the authentication information is a string. And then the complementary information is actually the hash. And it has 2 parts. So the first is the hash ID, like 2 characters representing the hash ID, and then concatenate it with an 11 character hash, which is the hash of the authentication information. And in terms of F, which is to, map from A to C, you could use a so-called crypt function. If you just like search crypt in Google, you can still get this information like from Unix. how the script work, etc. Or you can have like modified DAS, which we just learned about DAS, or MD5 to generate those complementary information or to output the complementary information given name. All right. And then for L, which is, the actions that an object will do on behalf of identity will be like to log in. I'm going to log in to the system, or as you, meaning that you are going to right now act on behalf of someone. So it's like if you have as you, say tval, that means that you are going to using my account, which is tval, as the current account and try to behave on the system. So like su is a command in Linux system. Okay, and then for S, which is you can set up password or you can change password in Unix encrypted password system. You can use password D or it needs password D or password plus. Like those are the common command that you can use to change the password. And if you're interested in more like details, you can check this website. But for now, it's good as long as you know, like this example, what are those informations in the Unix encrypted password system. Okay, and then the way, by the way, is this clear enough? Just double check. All right. And then in the Linux encrypted password system, the way that it works is that there are, a service provider, which is the system that are trained to interact with subjects, or say like external identities, or like the true person, like the principal, right? Like Tiffany or Alice, okay? And then when someone wants to have a credential from, or say have an identity from the service provider, it will first call us to create a password. And then the service provider will ask the identity, okay, so what's your password? Okay, and then it will set up a password. For example, we can just use password itself as the the password token, although it's not secure, but let's right now just use this as an example. So Alice is going to tell service provider that, hey, this is the password. And then inside service provider, it will use F. Remember that F is the complementary information, like the F is the complementation function. It will output complementary information. So service provider will use F to generate an encrypted password. And remember that when we talk about the first password system, we said that those plain text, they're not secure, right? You don't want to store plain text as the password. You want to store those plain text and password in your system. So now, instead of really storing the plain text, it's going to generate this encrypted password and then store that into the system, like the service provider, which is the system. So there's no plain text password, but then instead it will have this decrypted or hashed information store that into the system. And we know that like without a key or without like hash function, because it's one way, there's no way for you to look at, or there's computationally infeasible. I shouldn't say there's no way, because there is always a way, which is the brute force way. But computationally speaking, it is infeasible to recover the password given this one-way function and hash the result, right? Sorry, I'm looking at the Zoom now. Sorry, I'm looking at the chats. I got a little bit distracted. Okay, so Thomas, I am looking at your chat right now. You said that could you go back to the previous slide after I'm done with this one? I just want to make sure which slide that you want to talk about. Is that this slide? You mean the slide that before this one? And let me know, and if so, I will turn it back later on after I finish this slide. All right. So now I'm gonna continue. So now, oh, okay, yep, no worries, Thomas. So now we have this information that is stored in the system, right? And then we know that here password is the set password from Alice, which is the authentication information. So it's A, right? And can someone tell me, well, actually, I'm gonna just answer this by myself because it is a very straightforward answer. And this part is C. So this is the hashed, or say the complementation functions output, which is the complementary information. So you see that in this case, A, which is authentication information, is not stored in service provider. It's not stored in the system, but instead the complementary information is stored in the system, right? And then for L, which is authentication function, a verification function, so it's gonna take A and C together and then return true or false. And can someone just like at this one tell me, in this case, then how a service provider should work in order to use A and C this information to output true or false? Yes.
You hash the password the user gave you and see if it matches the hash on file.
Exactly. You hash the password that the user gives you, and then you match that result with your complementary information, right? So basically, here what we're gonna do is whenever a subject tries to log in, it will enter this password, like authentication information, or say the field authentication information, and then the system will use this information and then to generate the according complementary information according to users input, and then compare that complementary information with the complementary information stored in the system. And then if they're equal, that means that yes, the authentication information is correct. Otherwise, it means that it's wrong, right? So in that way, just like do a complementation function and then do a comparison. Okay, good. All right. Okay, so now let's talk about attack. Since we have, this is the cybersecurity class, we obviously need to think about this from both defender and attacker. So for high level, like on the high level, the way that we can attack authentication is that the goal of attacker is try to find the A, right? So it's like, this is one way that the attacker can generate attack, or say, this is one possible goal that attacker can do. If attacker can find the right A, then, which is like the password, right? So then attacker, of course, can log into the system. And is there any other possible solutions for the attacker? If attacker wants to, impersonate an identity. So one way is to get the A, the authentication information. And what about the others? Sorry, say again? Yes, so the other way is to get complementary information. But then looking at the Unix encrypt system, this is a little bit less possible, but for, maybe I should say in this way. So in the entire authentication information, authentication system, ultimately you need to use the A. If you only have the complementary information, but you don't have the authentication information, you still will not be able to log into the system as an entity, right? So think about you log into the website, you know this person's secure question, but you don't know this person's password. It's still not going to work, right? That's why it's called complementary information. So, but this is something that closer to the answer. And then I want you guys to spend a couple more seconds to think about, is there any other way, especially for for the Unix encrypt system, is there any way for you that you can log into the system? Oh, yeah. Say it.
If you figure out how to reset the password.
Yes, yes. If you can figure out how to reset the password, that's right. Okay, so here, another way that you can log in the system is that even though that you cannot find the right A, like the true authentication information, you can still log in if you generate another A, or say you can find the complementation function, that you can generate the right complementary function, complementary information, right? So it's like if we go back to this part, the way for Unix encrypted password system works is that it will take an A and then calculate the complementary information. So it doesn't really matter what A is. As long as the C is correct, you can log into the system. So in this case, then if you can find, another A that can come, like they can output the same C, even though the A is not correct, you should be able to still successfully log into the system. And this, this of course is for some specific kinds of F, like the, complementation function. For example, if the complementation function is a hash, then all you need to do is to find a hash collision, right? Just like you find another value that can output the same complementary information. Right, and then going back to Louis' question on chat, so this is equivalent to two keys given the same index in a hash function. Yes, so that is a, that is exactly it is. So it is hash and collision, right? Okay, and then as I said, like attacker has a C, and then attacker just try to find an A, such as f of A is equal to C, right? Or if attacker doesn't have the complementary information, he can find the A and then make sure that the complementation function and with the A will return true for the verification function. Okay, so given all those kinds of attacks, right? So we can try to find A, or if we know the C, that we can try to, and also we know the F, then we can find another A that can make F of the A, say A prime, equal to C, right? It's like a collision, right? Or we can just find the way that can output true for verification function. So then how can we prevent attacks? If you are a defender, you know that those are the possible ways that the attacker can do. Yes.
Solve the password.
Store the password?
Solve the password.
What do you mean to solve the password? Yes, yes, that's a direction. So, but I want to have a more kind of a straightforward way, basically. It's like, if you are a defender, what you could do, just not give attacker those information so that attacker can attack, basically. So, for example, the attacker, defender can just hide those A or F or C. Right? Just like those can help to prevent. This is like more straightforward, just like this is a pretty simple way, right? You just hide those information so that attacker will not know what A is or what C is or even what F is. And in real world case, this is the so-called shadow password files. So question, can we hide L? Remember that L is the verification function. So if we hide L, then we can prevent attackers from knowing if the guess is successful. For example, like say a honeypot, right? So you ask the password, attacker types it, but no longer, like no matter if the password is successful, you obviously return the attacker a shell. But then one shell is the true shell, the other shell is just a fake shell. Because whenever you know that someone is logging with the wrong password, you just return them the false shell. Although it looks like identical, or it looks identical to the true shell, it's not really interacting with the system. So this is the way that you can prevent attacker from knowing whether or not his trial is successful. Or also what you could do is you can prevent, any network-based login, or just like restrict that to certain IP address. So this is like the way that we back to VPN. So it's like we use this IP restriction information, and then we can hide L over there. Okay. And now let's talk about, password-based authentication. Okay. So for password-based authentication, it is very common, right? So we use it a lot in our real life. We log into our system, you log in with your own laptop. Like I myself log into my Mac, I use password, right? However, we all know that just like password is probably not enough. I just quote a like something here. Password, the worst form of authentication, except for all the other forms have been tried from time to time. And we know that it has a lot of problems for password-based authentication. So can someone come up with some, disadvantage for password authentication? Yes.
People tend to use personal information. So it's just the password.
Yes, it's easy to guess. And what else? Yes.
And most of the people have same password for multiple accounts.
Mm-hmm.
So if somebody gets access to one of your passwords, they can access another account.
Exactly. Yeah. So it's like people tend to, some people, they use the same password across multiple websites. So as long as one website is bleached, the other websites will also have the password of this particular person, right? And I'm looking at the Zoom now. General people use the same password as we'll say, and yes, right? So that's the problem. And also if someone has a weak password, as I said, they can be easily compromised. Yes, it's like password can be guessed, right? Also, it has something that you remember. So it's not completely random or complex because you have to remember that, right? So like if you're gonna just, of course, you're not gonna use like password generator or password management the system. If you just like manually remember that, then you have your brain doesn't train you the way that you can remember something random. So it has to be, it will be very likely, as long as unless you are super talented, you can remember random strings, but then it's going to be highly possible that you have a not complex or not very random string, so that it will be easier for other people to guess. And then yes, and even though that you are using password managers, and that just gives them one critical vulnerability, right? So it's like as long as you compromise your password managers, all the password over there will be compromised, right? So that is like a single point failure. Okay, and as I got said, easy to guess, easy to snoop, easy to lose, and no control on sharing, right? So it's like I can share my password with someone else, and then someone can just act on behalf of me. But if that person just happened to, leak that information to someone else, and then anyone in this classroom can impersonate me. Like social engineering, this has been happened for many times. Like you make a call and then someone will scam you, say, oh, now you need to log into the system. But then you have to tell me, you have to tell me the password so that you can continue, right? Something like that. And then in this way, you just leak your password. And in practical, even though that you are secure enough, you don't tell other people your password. Only you know it. But sometimes at the time that you submit a password into the system, for example, you submit your password, you log into the website, but then the website doesn't have HTTPS. It doesn't encrypt message. Then by the time that you type into the password and submit a password on the wire, anyone like in the middle or anyone that is eavesdropping the network will be able to get your password as the plain text, right? So also, like as we just discussed, it's likely that people will reuse password, and that will also cause issue. Okay, so then, you know, as we see, there is many issues. There are many problems with password-based authentication. And then now let's talk about the first possible attack, which is dictionary attack. I believe that many of you have heard about this before. So it is a general attack for all password-based authentication. And as I said, it's a dictionary attack. And then it's just like try each of the word in the dictionary and then try to compute the, you know, the information and then check if the information, like the F of W is same as the complementary information. And if so, then we just use that as the password. All right. So question, is it possible to search all possible passwords? What do you think? This is an open question. Yes. 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 Uh-huh. Right. Yeah. I mean, theoretically speaking, it is impossible because there are infinite number of possibilities, right? So that's why we say that, I mean, theoretically speaking, it's not going to be possible. However, because people will have their different like habits, many people will use like simple password. So technically speaking, or say in practical, it's actually easy to search likely password, like for those passwords that people use that for many times. And an example will be like John the Ripper, the password cracker. So it is an open source and then tools that you can just use, and it comes with a dictionary that you can just try those, you know, highly used password from the dictionary. And you can make this offline. So it's like, if you know the complementation function and you know the complementary information, all you need to do is to, you know, have a dictionary and I try them out. And as long as you find the right word that maps to the correct complementary information, you're good to go. All right, yes. And then as Lou said from a chat, you know, finding all the possible or iterating all the possible will be time consuming, and then more than that, not even time consuming, because there is infinite number of possibilities. It'll be just like technically speaking, it's impossible. Okay, and then what you could do online is that you can also, what you could do is you just try all the different kinds of a dictionary word, right? Suppose that you have a system and this system will always just return you, yes, successful, or no, fair, right? It will tell you whether or not your typing is correct. Then you can just try that as long as, you know, for as long as you want. So you can try that, and then whenever it returns you true, you know that you have the correct information and use that for login. Okay. So how can we defend against the password guessing? Just like the way that we do, we mentioned for this online and also this offline attack. So for example, what we could do is we don't tell the attacker, or we don't show other people this complementary information. So there's no way for them to find the right authentication information using offline way, right? Because they no longer know the complementary information. In this way, all guesses have to be online, right? And then when it turns to online, what you could also do is that you can limit the number of trial. And this is, many systems already have these features right now, right? Like if you log into, a website and then you try that for some times, and then they'll tell you that, okay, now you are exceeding these trials and you have to wait, or it will just like ban you over there, right? It will lock your account. And also, what you could do is you can increase the time to compute the f of a. So it's like the complementation function can be extremely, not very extremely, but like it can be long, so that if someone is going to access online, or someone's going to try that offline, for them it has to spend much more effort, like much more computing resources in order to find the right answer. However, this can also be a harmful thing for the defender, because that means that whenever someone's going to log into the system, when we do validation, remember that when the Unix password system, when they do validation, it will still have to do this complementation function computation. So that will also makes this part of the computation, like for defender, for the system to become harder, because now you have to, the function itself becomes more complicated, right? So this is like, it's a double-sided sword. Both attacker and defender may have to suffer from this. All right. So now there's the next way that we as attacker can do, which is rainbow tables. All right. So here, what it does is that it will essentially pre-compute the size of some key space. Okay. So that just like it pre-computed for the rainbow table and then store that in the table. And then rainbow table will allow a trade-off between the time to crack and also the space, basically because it has pre-computed those information, right? However, the requirement of the space can be large because, as I said, like it pre-computes some information, so it has to store somewhere. And for example, for MD5, 1 to 8 character in alphanumeric, it will need 127 gigabyte. We think that, okay, that is still reasonable, especially for our current storage. But then increasing from 1 character to like increasing from 1 character by 1 more character. So it's like increasing from 8 characters to 9 characters. It will kind of, it's not even just double, it will make this original storage size times 4. The 4? Yeah, it's like kind of like times 4, right? So it's like if you only increase your password by 1 character, and then for rainbow tables, in order to store that information, pre-compute that and store that in a table, it will increase like 4 times of the original space. So in this case, if you are a defender and you want to defend against the rainbow table, you need to make sure that your password is long enough so that the attacker will not be able to really store your password into the rainbow table. Okay, then how can we possibly attack or to defend the rainbow table besides setting a long password? So think about this, like back to Unix encryption password system. You can only set password up to 8. Okay, So if that is the case, then as a defender, when you design or when you renew your encryption system, how can you do to add some diversities into the system so that the rainbow table will not work? So the way that you could do is to add the so-called salt. So salt is just a random value, just that people give it a cute name, it's called salt. So it is a random value to each password before it is hashed. And then the salt is converted into a 2-character string. So you see that it's not very long, it's only 2 characters. Means that there is only 16 bits, right? So it's like 2 bytes, right? So, and then the salt is stored in the /etc/password file along with the encrypted password. Okay, so it's like salt is something that is stored into the system itself. But then the salt information is not going to be public. It's not going to be disclosed to anyone else, like the users or say the attackers. Well, I mean, salt is public and known. And like when I say it's public and known, it means that this salt information is public in the system. And also having the salt is known by the attacker. But then because of the salt, each password hash is going to be unique, even though someone is going to use the same password. And because of the different salt, the hash, the value will be different. And that will be, essentially selecting a different app for every user, right? So that means that even though that originally the complementation function is the same, because every user is using a different salt, it's kind of changing this complementation function to a more diverse complementary function, because it always takes a different argument, a different salt as the argument. All right. Okay, so this is an example with modern crypt, which is the app function, right? The complementation function with salt. So if we look at a file, like if you have a Linux machine right now, you can take a look at your /etc/shadow file, and then you will be able to see a string like this. Okay. And then now let me just also turn on my virtual machine and show you. All right, Zoom people, can you see my machine? Cool, thank you. Okay, so here you guys see that this is my Linux machine, and you can see /etc/shadow. Oh, let me see if I type something wrong. Oh, I see. So first of all, let's check the permission. So see that it belongs to root, and as a common user, I don't have the permission to read it. And that's why if you open it here, you see that it's all empty, right? And then if you look at the message here, it says permission denied. It means that as a low privileged user, I cannot read it. And now let's just log into as the user, as the root. And then let's take a look at the shadow file. Now we can see it. And you see that this is the information about Tiffany B herself. Okay, so there are multiple fields here. the first field, it has a 1. It specifies the specific like encryption algorithm, which is the complementation function. So it used this number to specify which complementation function that I'm using. And then this part. So by the way, each message is separated by a $, right? So here you see this part. This is the salt. So this is the information that the system has. This is the salt. Sorry, no, sorry. This is not the salt. This is the complementary information. As I said, salt has only two bytes. So this is not the salt. This is the complementary information. So this is like after you do this encryption with the salt together, this is the result. All right.
Salt is one. Salt is one.
No. Sorry, what did you say?
What is salt?
Oh, salt is a random value. So
With these 2 bytes, is it LP maybe?
just give me a second. I think. Let me say this again. Sorry, I misspoke. Let me say this again. So salt at the beginning is 2 bytes, but now they extended to more bytes. Actually, I was right at the first place. This is the salt. This is the salt. But just like at the beginning when salt was designed, it was firstly only 2 bytes, but later on it extends to longer so that it will be more secure. And this part is the salt. Okay. And then after this $, this part, into the column. This part is the encrypted password. So this is the so-called complementary information. It's like it is the encrypted password and with the salt altogether. So now, if a user is going to log into this system, my Linux machine will first check, who this user is trying to behave, which is Tiffany B. All right, and it's going to extract this information, which is the salt. It's going to use the salt information and then compute the encrypted message along with the salt and the authentication information inputted by the user. And I'm going to match the result with this result, with this string. And if this is the same, then it's going to return true, meaning that it's going to grant the user to log in. Otherwise, it will just say false and deny the login. Okay? Yes?
What is the purpose of one?
So the first here, 1 means the type of encryption. So in Linux system, there are multiple types that you can use when you encrypt this message, like encrypt this particular password with the salt. And 1 means that he just specified this specific one, like from crypt 16. And there are also other ways, like crypt 16 has also different kinds of variations. And I specified that for crypt 16, for this crypt encryption with this specific setup. All right, let me go back to the slide. All right, Zoom people, I suppose that you can see my slides. Yes, thank you. All right, I am going to continue. Yep, as I said, the first part is specify the encryption algorithm. And then the second part is the salt. And then the third part is encrypt the message with the salt and authentication information. All right. Okay. So there are some variations about the encryption message, the encryption algorithm. As I said, there are different ways. And here in the previous string, I specified a number 1. This is 1, and there's also other ways. So it's like you could use bcrypt or scrypt. There are all ways that you could use to, make your encryption more advanced. And using this way, they kind of try to slow the hashes so that for attackers, it's gonna be less possible to do an offline guess. Okay, and now let's talk about password reuse. We just mentioned about the weakness of password based system, right? Password authentication system. One problem is people tend to reuse their passwords. So I'm just curious, how many passwords do you really have? I have someone, I'm not gonna say who is, but someone told me 3. Okay, raise your hand if you have more than 5 passwords. Great. I was about to say raise your hand if you have only 1 password, but I decided not to ask that because I don't want to de-anonymize you. So good. I am happy. And then raise your hand if you have 20 more. Great. I suppose that you have a good password manager. Do you use your password manager? Okay, not use your brain.
No.
No, good. Or maybe it's not bad. I mean, or maybe it's bad. I don't know. If your brain is good enough, then you should use your brain. Nice. Okay, I do saw someone from chat that said that he has only 1. Okay, so and I think it's very likely that some of my friends they also use 1. I wouldn't be surprised that if someone told me that he has only 1 password. But in any case, good. So we have some of reuse the password, and then I just wonder for those who reuse the password, what kind of service, or say like what kind of website or what kind of a system that makes you to reuse your password? Have you thought about like, I'm reusing this password. Why am I reusing this password? Or put it this way, I can ask you another way. Why do you decide to use a different password when you are like registering yourself to somewhere? Yes.
Maybe for like a bank account or something.
Sorry, so they can create a.
Maybe for like a bank account, for example.
Okay, so it's like a banking account, right? So you tend to use the same password from your banking account? No, good. I'm happy to hear that. Awesome. So, question, are they all equally secure? So put it this way, suppose that you have a pretty complicated password, right? And then the question is, now if you're gonna reuse them, then does it mean that they're equally secure? No, right? And then what happened if one of your passwords leaked? As we just discussed it before, if one got leaked, and it's likely that people will have that, and then people can use that, putting that in their dictionary, sell that in the black market, so that everyone will know that this is one of the possible passwords. They start to attack them, or they start to prioritize them when they do brute force, right? So there is a lot of interesting or bad infamous real world cases that causes a lot of damage. So for example, password leaking of Yahoo 2013, it causes 3.5 billion loss. And for Adobe Friend Finder 2016, it has like 412 million loss. Adobe, eBay, a lot of loss because of password breach. Okay, so let's talk about one example, Adobe breach. Okay, so the way that Adobe works is that when the database was breached, people found that they didn't store the plain text password, but they store the complementary information as the plain text in their database. But then when people set up their like password hinting method, which is the complementary information, they sometimes they just leak their password over there. For example, like the way that it works for Adobe is that it has the user ID, it has the user name stored as plain text, and then it has, email address also stored as their plain text. And then, well, actually, for email address, it's not really stored as plain text, but it stores this information of which email address it is, right? And then they have the password data, which is good. It is actually encoded. By the way, I want to emphasize that this is encoded, but not encrypted password, which means that this is insecure, right? Because as we discussed in our crypto sessions, we mentioned the difference between encoding, decoding, and encryption, decryption.
Like, they literally store it in this.
Yeah.
That's stupid.
Yeah, I'm pretty sure that they don't do this anymore. But this is what happened for the backward this Adobe Bridge. So they just store the password data as base64, and also they have the password hint. And then, as I said, even though that they store the password encrypted, because they store the password hint in plain text, it still can cause a big damage, which I will later show you. All right, so those are some password data and also the password hint. Again, this is encoded and this is plain text. And even though say this is encrypted, because of this, you can still somehow be able to guess what the password is. All right. And then the way that we could do is, we can just have some statistics over those passwords. So for example, we have this is the encoded password value. And then we have this like the, say like population. It's just like 1.6% of the people, they tend to have this same password. And what you could do is you can also just search online, say, and check those most popular passwords. Like, what are those passwords that are most popularly used in daily life? And there is statistics about that. And actually very interesting. You can, sorry, for a second. And you can see a very close, or it's like almost like one mapping between what you count, what you like the statistics from Adobe to the statistics from real world. So for example, here, yes. So it's like password hint tells you, this is my password, take it, please, right? So it tells you those passwords, and very interestingly, you see that like for password 1, 2, 3, 4, 5, 6. This is the according data, right? This is the encoded password. And you check here, this is Adobe's result. So for this 1, 2, 3, 4, 5, 6, oops, sorry. It has the most popular data, right? So most users use this password. And you compare that to the real world statistics. It does have like a lot of people. It is also the top password that has been used in the world. Right? And then back to here, there is a little bit longer, slightly better, but still pretty bad, which is 1, 2, 3, 4, 5, 6, 7, 8. It also has been used like heavily. So this is according to the second part. So this is the second data. It is pretty, there's still a lot of people using it. And then comparing that to the real world statistics, it's also like maps pretty well. And similarly, there's password, and this, I didn't recognize that at the first time when I do that. Is that a real word like QWERTY? But then I later on realized that it's just, if you look at your keyboard, that is the keyboard letters, QWERTY. That's just like left hand keyboard, 1, 2, 3, how many? Okay, 6 consecutive letters. Okay, so those are some interesting findings from the Adobe Bridge. And that's why you need to have different passwords. You want to have different password so that if one website got breached, the other website of your account will be fine, right? But then, as I said, if you're gonna have a lot of password, like 20 or 20 more, you probably gonna use password manager because you will need that to remember each system and the corresponding password. And of course, you also don't want to use weak password like 1, 2, 3, 4, 5, 6. You hope to have, you know, you hope to have a strong password. Hopefully, that's a nice randomized password with combinations of numbers, special symbols, etc. So, and in that case, you will need password managers even more. So, password managers helps to keep track of password and generate random password for website. Right? And the way that it works is that usually there is a master password that you need to remember. So in your brain, you need to have one password. But then after you have this one password, you can access your vault, which is the password and the corresponding website information. So in this case, who do you trust? You trust your password manager, right? So you trust that your password manager helps you to handle everything okay. And as long as you have your master key, you have all the other stuff. And you have, I mean, right now, you have many options that you can use as a password manager. You could do like LastPass, 1Password, KeePass. I mean, they have pro and cons, so you can decide which one that you want to use it. Okay. And then the question is, what happens if you forget your password? Will you become like completely locked out of the account? So right now, most of the system, if you forget your password, you can say, forget my password, and then they will send you the information to your registration email, which is nice. And then you can reset your password. So question, is it secure? No. Why not? Exactly, yes. So hacker can access your email if he has the access to, it has the password to your email, and then he can click this, reset, and then reset your password, and even worse, set the password to the way that you cannot log in. Okay. And because of that, attacker can access your email, and we have a more complicated way to authenticate people, which is the two-factor authentication. Okay, and then given the time, I'm gonna stop here, and then we're gonna continue to talk about this on Thursday.